Guys, this is video 13.6. We're going to be talking about Le Chatelier's principle today. This is something that, it's not super, it's super easy once you get it, okay? So it could take you a little bit longer than the person sitting next to you. I have lots and lots of practice, and if you're confused as you're going through stuff, ask, okay? Don't hesitate to ask for help or questions. I have some different analogies. One of the things analogies that I've always told students to think about is kind of like tug of war. Within this system, you have a tug of war going on between the reactants and the products in a reaction, okay? And one side is going to pull harder than the other, and that's kind of what this principle is dealing with, okay? So what Le Chatelier's principle explains is how a system at equilibrium, so closed system, will respond to stress. All right, so just like you and I, when we are stressed out, we will respond in a certain way. Do people like to be stressed out? Absolutely not. All right, you guys, where you're at in life, you're stressing out about tests and, Regents exams that are coming up, and I know I'm not helping with that when I remind you of it. All right, I know for me, I'm stressed out about my kid and, not sleeping and stuff. So none of us like to be stressed out, but stress is always there. But there's things that we will do to try to relieve that stress because nobody wants to stay stressed, and reactions are the same way. They don't want to stay stressed. Okay, now the stress that we're talking about in terms of a chemical reaction is any change in temperature, concentration, or pressure. Okay, so those are the stresses that we're talking about, and when one of those is either added or taken away from a reaction, all right, something will change. All right, so when a stress is added to a system in equilibrium, the system will shift in order to relieve it, okay, and reach a new equilibrium. Now, the shift we're talking about, guys, is either it's going to shift towards the products or the reactants, okay? And we'll talk more about that here throughout it. So the shift, it's an increase in the rate of either the forward or the reverse reaction. So you're either going to shift toward the products or you're going to shift toward the reactants. So if we shift to the right, that means we're going toward the products. Don't overcomplicate this. Don't overthink this, okay? You guys know that the right side of the arrow is the products. So if we go to the right, then we're going toward the products. And if we're going to the left, then we're going toward the reactants. So if we shift to the right, that means the rate of the forward reaction increases. And how we would show that, all we show is that, hey, it's shifting to the right. We show that by just drawing an arrow, pointing which way the equilibrium is going to shift. So if we were to draw and think about it like a reversible arrow, right? So like we've talked about that reversible reaction arrow. If we're going to do it to where it shifts, the reactants are like this. So it's like that, okay? Our arrow is going to be not equal like it is in the picture here. That's where we're at equilibrium, where they're the same size arrows. If we're shifting, if we're shifting to the right, then our forward arrow is going to be bigger than our backwards arrow to help reestablish that equilibrium. All right. When we shift to the right, we favor the products. And what we mean by favor, that means more products are going to be made, okay? All right, more are produced. That's what it means to favor one side of the reaction or the other. Now, if we shift to the left, what rate is going to be increasing? Well, if we shifted to the right, the forward reaction increased. Well, if we shift to the left, that means the rate of the reverse reaction is going to increase. And how we depict this is with an arrow. So we're going to be looking like, we're shifting to the left. Okay, so that means it would look like this. We'd have a small forward arrow and we'd have a large reverse arrow. If we shift to the left, that means we favor the reactants. And again, I'm going to write it in here, and I want you guys, I can't stress this enough, okay? That means more reactants are produced. All right? Now, what we've just covered here in the last couple of minutes, guys, is the theory, okay? Kind of talking about what Le Chatelier's deals with, why it shifts like that does, now we're going to get into the stresses and see the effects that they have, okay? So the first one we're going to do is concentration, okay? Now, all the stresses we're talking about are initial stresses, not like later on in the reaction. These are like at the beginning. If we change it before the reaction starts, which way is it going to shift? So concentration as an initial stress, equilibrium changes or shifts when a reactant or product is added or decreased or taken away. So when we either add something, right, that means it's going to get the reaction to move faster, whatever side we add it to. So if I have A plus B yields C plus D, if I increase D and make D bigger, that means I have more products to react, more collisions, which means, oh, I can then start kicking it into high gear and start moving backwards. So we're going to kind of break it into two steps here. We're going to talk about if I increase or add a concentration first, what happens, and then if I decrease it. So if I increase or add, I'm going to shift away. Okay, so wherever you added to, you're going to go to the opposite direction of where you added. So let's go through these examples here together really quickly. Okay, and this is where I have lots and lots of extra practice, guys, once we get into this. So go through this practice with me. You have practice sheet in your packet, but then I have extra practice sheets, and I can get you even more if you want it. I promise you this will click for each one of you. If you're struggling with it, call me over. We can chat about it. All right, so if we add H2O, so first things first, guys, you got to find where your substances that you're adding or taking away. So H2O is right here. So if I add that, which way am I going to go? Well, notice, what is H2O? Is that a product or a reactant? Well, here's my arrow, so that means H2O is a product. Well, if I add or increase, I'm going to shift away. So it's on the right side of the arrow. That means I'm going to shift to the left, okay? So you can either write the word left or you can draw an arrow, because I want to go away from where I added to it. So that's the first thing you got to identify. What's happening to the equilibrium? Which way is it shifting? Now, there's a second part to this question. What happens to the concentration of ammonia? So I'm going to use a different color. Ammonia is right here. Well, if I add H2O and I start shifting to the left, what's that going to do to this concentration? Well, that means that ammonia will start being created more, because now I'm moving away from the right side where these guys are, and I'm making more of that. So my NH3 concentration is going to increase. And you can write the word increase, guys, or you can write an arrow if you want. I don't care. I'll know either way. Make sure you know what is going on. So that's our first example. I'm going to erase this. Let's look at number 2. All right, if we add O2 to the system, okay, so O2, find it first. Here it is. All right, there's my arrow. It's a reactant. So if I'm adding, I'm going away. Okay, so that means if O2 is on the left side of the arrow, I'm going to shift to the right. Okay, I'm going to go to the right. Now, find NO. This is where I'm going to use a different color. Here's NO. Well, is that on the right side or the left side of the arrow? Well, it's on the right, so that means NO is going to increase, because that's the way that I'm shifting. If I shift to the right, that means it's going to increase toward wherever that side is. All right, here we go. Number 3. If you feel good, guys, and want to take a shot at it, pause the video and do so. H2O. Okay. Oh, it's on the right side. All right, I'm increasing, I'm adding the amount of H2O that I have. I'm going to shift to the left. Okay. So what's going to happen to my NO? Notice this is one that's different than the other two that we've done. NO is also on the right, but if I'm shifting away from it, that means these guys are getting consumed. So that means it's going to decrease. It's being used up. Okay. In that instance. So each problem, guys, is its own problem. You can't think, oh, well, it was shifting, one way in the last problem. This is a new problem. Every single one is a new problem. All right, and number 4, if we added NO is right here. That means which side am I going to shift? Oh, it's going to go to the left. So now it's not asking you in number 4, where's it going to shift? But we have to know the shift before we can answer the concentrations. So it says if we added NO, which concentrations would decrease? So we know we're shifting to the left, so that means everything on the right side is going to decrease. So that means NO is going to, NO wouldn't decrease, guys, because it said we added it. So that means you take that one out. We have H2O would decrease, and we could also say that the heat would decrease. So that last one, I'll be honest, was a little bit more challenging. If you're confused with it, guys, keep working through this, okay? Don't stress about it yet, hot pun intended. Keep working through it. All right, so if we add, we increase, we go away from where we go, or where we added. Now let's do the opposite. If we decrease, we're going to shift toward. All right, toward where we took away from. All right, so when the concentration reactant or product is decreased, reaction will shift toward that side that has experienced a decrease in concentration. So you replace what was taken. Go through the same thing. If we remove oxygen, so same steps, okay? We're taking this away, though, so that means we go toward it. Well, let's see. Oxygen is on the left side of my arrow, so that means I'm going to shift toward the oxygen because I took it away. So it's going to shift to the left. What's going to happen now to NH3? Well, figure out which side NH3 is on. Well, NH3 is on the left side, so that means it's going to increase because that's where we're headed, right? That's where our arrow is pointing. So I would encourage you guys to try 2 through 4 on your own and then come back and check it out. All right, number 2, water. Okay, so each problem is different. I'm starting over. Water's over here. Okay, if we remove water, it's going to shift to which side? Well, water's on the right, so that means I'm going to shift toward the water because I removed it. So I'm going to take it away. That means I'm shifting to the right. What's going to happen to my NO concentration? NO is also on the right, so that's going to increase because I'm moving in that direction. Okay. Number 3, if we remove ammonia, okay, which concentration or concentrations will decrease? So we're removing ammonia. First thing I identify, where is it shifting? Well, ammonia is on the left. We're going toward it, so it's going to shift left, which means the concentrations that are going to decrease are everything on the right. Okay, so that means in this case, NO is going to decrease. It means H2O. It means our heat is going to decrease as well. And the last one here, number 4, it says if we remove NO, okay, which concentrations would increase? So again, make sure you're answering the question that's asked, guys. Don't assume it's going to be the same every single time. So we're removing NO, that's on the right, so we're going to shift toward that. So it's shifting right. Which concentration or concentrations would increase? Well, if we're going to the right, guys, we said we're removing NO, so that's taken away. So that means H2O is going to increase, and it means our heat would increase as well. Okay, so this is only the first stress. I'm going to pause the video here in just a second and then do the other 2 in a part 2 so it doesn't get all messed up and it's not as long. Here's the big trick, guys. Remember, AA and TT. Okay, AA and TT. AA, you add, you go away. All right, so if you add something, you go away to what you added. TT, take, towards. So if you take something, you remove it, you go towards that. So take, towards, add, away. Memorize that to help you with the concentration piece.